Hello! I hope your day's been good so far, and we're going to look at exponents again, and I hope you will like this with me. We've already looked at what exponents mean, and now we're going to look at some laws of exponents, which just simply means how to work problems with exponents. So here we go. I've made a little graphic organizer for you this time on our paper. It's just a way of organizing material that helps you to think and learn it better. So let's get started. The first one I want to look at is called the multiplication law of exponents. And what it helps us learn how to do is what to do if I'm multiplying. I have a multiplication problem and yet there are exponents in there. So all I really have to do is think about what it means and I'll know. So let's do that. X to the third means, and you already know this, x to the third means x times x times x 3 times, and x to the second power means x times x 2 times. So I've got 2 more. So how many have I got all together? Well, I've got 1, 2, 3, 4, 5. So that could be written as x to the 5th. I mean, it's a shortcut, so we definitely want to write using our exponents to make it shorter. But this is really what we're thinking. We're thinking I've got 3x's times 2x's. So I've got 5x's used as a factor, 5x's as factors, so that's the same as x to the 5th. Okay, let's do another one like that. Let's say that we might have a to the 4th power times a to the 1st power. And if there's no exponent showing, there's a 1 there. There's an understood 1 there. So here we go. Let's say a to the 4th. Well, that would be 4 a's times each other. 1, 2, 3, 4. And then there's another 1, all multiplied together. That's what it says. So we've got 1 more. So all we ask ourselves is, how many have we got? Well, we've got 1, 2, 3, 4, 5. So our solution is a to the 5th. So a to the 4th times a is a to the 5th. And what should we be looking for patterns, you know, like always. So let's do another one. Let's say that we've got, choose a different color. Let's say that we've got w to the 2nd power times w to the 1st power. I don't usually put the 1, I just did that time. And let's say that I've got that times w to the 3rd power. I got to write all those out. If I don't know the law, we don't know it yet, so here I go. W to the 2nd means I've got to write w times w. W to the 1st means I just write w. It's just one of them, but they're still all multiplied together. W to the 3 means I've got 3 more of them. 1, 2, 3. And they're all multiplied together. They're all factors. So when I'm trying to figure out a better way to write my product than all this, which I don't want to do every single time, I count them 1, 2, 3, 4, 5, 6, and I get w to the 6th. And I know that some of you have seen the pattern, and that some of you are saying, I really don't want to have to write this out every time, so why don't I just know that's 2, know that's 1 more, know that's 3 more, and know that if I did write them all out, I would just get 2 plus 1 is 3, and 3 and 3 is 6. So maybe if that's you thinking like that, you would be thinking, well, heck, why don't we just take x to the 4th times x to the 2nd, and let's just say, well, that's 4 x's, and that's 2 more, so that would be 6 of them. That would be 6 x's, x to the 6th power would be the product. Well, let's try this one. Let's suppose we've got a to the 3rd times a to the 2nd times another a to the 2nd. You can write them all out, or you can visualize them all being written out. But think it through. This means you've got 3 of them, 2 of them, and 2 of them, all as factors, all multiplied together. So how many have you got? You've got 3, and 2 is 5, and 2 is 7. So you've got a to the 7th power. So you make up a law. I mean, you've been through several examples here looking at what happens when you multiply with exponents of the same base. And I mean, you saw what happened. You just simply put down that base, and which would be x in this case, and then you added the exponents, making sure that you stayed with the same base. So here, a to the fourth and one more, the base is a, add your exponents, a to the fifth power, and so forth. So our multiplication law really says, hey, whenever you're multiplying with exponents, you put down the base, and then add all of the exponents that have that base. And there you go. You watch your signs and other things which we'll do later, but these are your basic laws. Okay, well, what if you're multiplying? What if you are, I'm sorry, we did that one already. What if you're dividing? I've got a division problem, x to the fifth divided by x to the second. I've got exponents in it and I'm not sure what to do with them. Well, again, think about what it means. Use your understanding. X to the fifth is 5 x's, so let's write them out. X times x times x times x times x over, which means divided by, x squared, which is x times x. I mean, that's the true meaning. This is a shortcut, which we love. This is the true meaning. So then we just cancel 1 for 1, because you know anything over itself is 1. And we said that we could just take a shortcut and cancel factors. We can cancel factors. So we cancel one of these with one of these, and another 1 with one of them. And then you see what's left over. Well, what's left over is x times x times x, which is x to the third power. And so that is the way, let's do another one of those. That's the way this one comes out. Let's see what happens on another one. Let's say that we've got a to the fourth power, and we want to divide that by a to the second power. Well, we use the meaning of exponents. We say a to the fourth means a times a times a times a in the numerator, and in the denominator it's a times a. And then we cancel, because we can always, and we want to always simplify as much as we can. So a over a and a over a is 1. So then all we have left is a times a, and we understand and know that that is better really written a squared, a to the second power. All right, let's do another one. Let's say that we've got c squared, or c to the second power, over c to the fifth power. And let's think about what that means again. It means that we've got 2 of them up here, and I've got 5 of them down here, so I need a little bit longer bar. So I've got 5 c's as factors. It's very important to understand and remember that those are factors. So here they are. C times C times C times C times C. There's 5 of them. 1, 2, 3, 4, 5. Do the same thing. C over C is 1. Cancel it. Use your inverse property. That one cancels with that one. You can only cancel factors. That's what we have, so we're good. We cancel that factor with that one, so all is great, all is well in the world. So we've got C times C times C, which we know is C to the third. It's on the bottom. It's fine. Just make sure you put on the bottom. You know, there's nothing there. What did we say in an earlier segment that we do? If there's nothing there, we put 1. Because really, C over C was 1, and C over C was 1, and 1 times 1 is 1. So when everything cancels away, it's 1, so make sure you write that down. And so your answer is 1 on top in the numerator, C to the third in the denominator. And that is an example, or a few examples, of what to do when you're dividing and you have exponents. So look at some patterns that maybe you noticed. You noticed that every time we just canceled away. And you want to know, do I really have to write this out the long way every time? No, you don't. You really don't. You just can understand, you have to understand that their factors really are there whether you write them or not. So you could take a little bit of a shortcut, let's say on this one up here, and we could say, this is division. I know there's really 5 in disguise up here, and there are 2 factors here. So I could cancel away all 2 of these with 2 of these. How many will I have left? Well, if I cancel 2 of these and 2 of those and I add 5, then I've got x to the third left. Now, very important to say, where are they left? They're left on top. There's nothing on the bottom. There's your 1 again. X to the third over 1 is x to the third power. So if the bigger number is on top, they're left on top. If the bigger exponent is on bottom, they're left on bottom. So when we did this one, we could have just said, hey, let's just cancel these 2 completely gone with 2 of those, and that will leave us 2, and they're on top, there's nothing on the bottom. A to the second over 1 is a to the second. You like the shortcut? If you don't have to use it. You can write it out every time if you like to, and I would for a while, but not always, not forever. And then down here, the shortcut would say, let's cancel those 2 with 2 of those, that leaves me 3. Clearly on the bottom, that's where I better leave them. Nothing showing on the top. 1 divided by c to the third is my solution. So a little bit of a shortcut there as well, and we're going to review these in a little bit. Okay, the next one, the next situation that you run into sometimes is, I call it a power of a power law. So let's see what I mean by that. I mean, I've got x to the second, well that's a power, an exponent is a power or a degree. And then I've got another power. So I've got 2 powers right together. I've got the power of a power, or I've got a power raised to another power. You can say it either way. So I'm like, well, again, you think about what that really and truly means. It means that I've got x to the second power, and I've got it 3 times as a factor. I've got 3 of these, 3x squares as factors. So I've got x squared times x squared times x squared. All right, now I'm going to do this the longest way possible in the history of the world, because I want you to understand it, and then take all the shortcuts you want to take, because I will, I'll assure you of that. Okay, so now we said we've got 3 x squares, there they are, and every one of those x squares is 2 x's. So x squared, that's 2 x's, that's x times x as a factor. There's 2 more. 2 more. And you're like, man, okay, how many have I got now? 1, 2, 3, 4, 5, 6. My solution, x to the 6th power. This little list of factors probably reminded you of the multiplication law. Because once you understand that this means 3 of these as factors, it is the multiplication law. So very, very much alike. All right, let's take another one. Let's say that we have, we've got a to the 4th power, and I want to raise that to the 2nd power. So I've got a power of 4 raised to a power of 2. And they're right together. They're just like about as close as they could get. So they're right together. That's how you know when you've got a power to a power. What does it mean? It means I've got 2 of whatever is in parentheses. So I've got a to the 4th times a to the 4th. And you're like, well, what does that mean? Well, you know what that means, and I'm not going to write this out as long this time, because we know the multiplication law of exponents says, write them all out, add them up, put the same base, add the powers. So I'm like, well, I do have the same base, it's a, so I understand that's 4 a's and that's 4 more, so surely I understand that that's 8 of them without writing it all out. Abbreviations are wonderful, and exponents abbreviations, so as soon as we're comfortable, we want to use the laws and begin to abbreviate and not have to write it out so long. But not until you're ready. There's no rush. Okay. All right. Let's take one more. Let's say we have c squared, and I have it raised to a 2nd power. So I've got 2 of those. So I've got a c squared times a c squared, because I got two c squares. So there they sit. If you already know the answer, say it to yourself or say it out loud. C to the second times c to the second is, and if you're not so sure, because if these are running together or you're just not sure, you say, well, then go back to what it means again. C squared means c times c. C squared means c times c again. What does c times c times c times c mean? Well, there are four of them, so that means c to the fourth. Perhaps you recognized here that you were using your multiplication law of exponents and you had the same base, so you could just put down the base, which is c, and add your exponents 2 and 2 and get 4, and your solution then would be c to the fourth power. So once you know your power properties or your laws of exponents, there are 3 of them here that we've done so far, you will be able to encounter and successfully encounter most any problem that comes your way with exponents. This concludes our introduction with exponents. Much more to come in the next Algebra 1 video. And so I'll see you on another day, and I hope you enjoyed this one. That's what it's for. See you later.